Not sure why, but people often struggle with perpendicular lines. When finding the equation of a perpendicular line, all you have to do is find the negative inverse of the slope of the original line, or the gradient of the original line. So the negative inverse of 3/4 is negative inverse. Okay, if you have a gradient of negative 1/2, the gradient of the perpendicular line is going to be negative, change the sign, and switch it around. Switch around your numerator and denominator. So that's going to be equal to 2. So the gradient of the line that's perpendicular to 1 with the gradient of negative 1/2 is positive 2. Okay, let's say we have a line with a gradient of 5/4. Okay, negative inverse. Now that we have that established, find out if this is true. So let's stick with the same equation, but we're going to find, instead of finding a parallel line, we're going to find a perpendicular line to one with the equation of y is equal to 5x minus 4. So what we're going to do is we're going to take the negative inverse. So change the sign, switch around the numerator and denominator. And are those perpendicular, these lines? Do they look that way to you? They do to me. And I'll tell you, I know with 100% certainty that they are perpendicular because their gradients are negative inverses of one another. We're going to look at this problem. We've got to find the equation of a line that passes through points 15, 3 and is perpendicular to a line with the equation y is equal to 1/5 x minus 2. It's perpendicular to a line with a gradient of 1/5. So we have to find the gradient of this new line, negative inverse of 1/5. Negative inverse, so we know that our new gradient is negative 5. And now we can proceed. We can use this point that we're given, which is 15, 3. We're going to put the 15 in place of x, and we're going to put the 3 in place of y, and we're going to figure out what our new y-intercept is, for what the y-intercept is of this perpendicular line. So just use a little bit of algebra and you find out that I believe it's c is equal to 78. And now we can rewrite our equation. Here's one that I feel is even easier than the previous one. We've got to find the equation of a line that has a y-intercept of 9 and is perpendicular to a line that passes through 4, negative 2, and 8, 6. Some information about this line without having to do any work. It's stated right here. It has a y-intercept of 9. So I know that I can write y. Okay, so I can write y is equal to mx plus 9, because we know that it passes through the y-intercept at 9. The only problem is we don't know what the gradient is. But we do know that it's perpendicular to a line that passes through 4, negative 2, and 8, 6. Well, that's easy. We already know how to do that part. We can find the gradients of this line. We can find the negative inverse to determine the gradient of this perpendicular line that's in question right now. We've found this gradient of this line. Now we have to find the gradient of the perpendicular line. What have I been telling you? Negative inverse. Negative inverse. Now we can rewrite our equation. We know the intercept is 9, and we know our gradient is negative 1/2. So y is equal to negative 1/2 x plus 9. We're finished with that one. Try this one on your own. And this should be your solution. Y is equal to 1/2 x minus 23 halves.